let's come to the second question now. See, the second question is from complex number. I'll be using the geometrical aspect of the complex number to solve this question. Let's start. So z1 is a variable point on this, satisfying this condition. Now what does this condition tell us? This condition tells us that z1 lie on a circle whose radius is root 5. So z1 lie on a circle whose radius is root 5, because mod of z1 is root 5. Okay, so and mod z, what does modulus of a complex number represent on the Argand plane? It represents distance of the point marked on the Argand plane z from the origin. So that's the modulus. So if the modulus remains constant, that means its distance of z on the Argand plane, wherever you mark it from the origin, its distance is going to be the constant, hence it will move on a circle with center at the origin and radius whatever that constant distance is. Okay, so mod z is equal to root 5. So on that circle lie our z1. Argument of z1 is 0 to pi. Now that's again an information. So argument of z1 is 0 to pi means it has to be on the upper half of the Argand plane. So it will be lying on the upper half only, either in the first quadrant or in the second quadrant. Okay, and then b, z2 and z3 are fixed points which are roots of this equation. So z is power 4 minus 6z square and then plus 25. So let z square be t. So I will be taking the quadratic as t square minus 6t plus 25, applying Sridhar formula to get the root. So I will say, okay, t is 6 plus minus under root of b square, 36 minus 4ac, 100 by 2a, so 2. So t is actually z square. Okay, so z square is, this is 3 plus minus 64. So it will be 8 iota. So it's not 8 because I already divided it by 2. So it has to be 4 iota. So what does that mean? Mod of z square is what? 5. But modulus has a property and which says that modulus of z is power n is same as mod z whole is power n bachcho. Okay, so using that we can say, okay, mod z whole square is 5. Now what does that mean? Both z2 and z3, which are roots of this equation, also satisfy the same equation. Which same equation? The circle's equation, mod z square is equal to 5. Okay, so z2, z3 also lie on the same circle. That's it. Argument of z2 and z3, okay, minus pi to 0. Now what does that mean? So argument is from minus pi to 0. That simply means that your number, the z2 and z3 lie on the lower half of this circle. z2, z3 lie on the lower half of the circle, I mean below the real axis, and z1, which is a variable point, z2, z3 are the fixed points. Okay, so let's fix those 2 points at least. So let me say this is b, which is z2 here somewhere, and this is c, which is z3 here. Okay, now let us put z1 somewhere, anywhere, maybe. Okay, so I'm calling this as, so I already marked z, so I'm marking it as z1 now. Okay, now let's read the question. The statement is find the circumcenter of the triangle ABC. So that's done. They lie on the circle of radius 5, center at 0. So that's the circumcenter. So therefore answer for the first part of the question is circumcenter is origin itself. Okay, because all the 3 vertices of the triangle lie on the same circle. So that's the circle, that's the circumcircle of the triangle itself. So that's so direct in case we use geometry. Okay, now also find the fixed point through which the internal angle bisects fixed point through which the internal angle bisects of angle A pass. Okay, so internal angle bisector of angle A pass, we have to find that fixed point. Okay, we have to find that fixed point. So let me draw that internal angle bisector. Let's say it intersects this circle here, which I am calling as D. Okay, so of course this angle is theta. Oh, let me erase this red part. Okay, so that's unnecessarily, that's creating a trouble here. Okay, gone. Right, just a minute. So right, So this, let's say this angle is theta. Since it's an angle bisector, this has to be theta. If I join BD and CD, if I join BD and CD, so that means using some properties of triangle here, I can claim that, see, if I consider what? If I consider BD to be the chord, then this chord subtends angle at Z1, which is theta, and the same chord BD subtends angle at Z3, and we know angle subtended by the chord on the same side of the arc is always equal. So this is to be theta. Similarly, if I consider CD to be the arc, this angle and this angle is same. So these two are angles same. So in triangle BDC, isn't that an isosceles triangle now? Because BDCD is equal to BD here. So it's an isosceles triangle. So which point is the fixed point? So the point D is the fixed point here. The point D is the fixed point here, bachcho. Okay, and which point is it? It's the midpoint of BC, arc BC. So D is the midpoint of the arc BC, since B and C are two fixed points here. So it passes through the midpoint of the arc joining vertex B and C here, bachcho. Okay, so that's it. Can we try to find this angle? So you people can try. Okay, to find not the angle exactly at this point using rotation. So you can try it. We may discuss this later, but okay, the fixed point is the midpoint of the arc joining the vertex or the points B and C on the circle, bachcho.